the chain rule. Let's assume that a variable quantity y depends on another variable quantity x, and x depends on yet another quantity t. Then the rate of change in y is equal to the product of these two rates of change. And therefore, dy by dt is equal to dy by dx into dx by dt. To understand this better, let's observe a gear system where a gear chain connects at least two gears together in order to transfer power from one to another. There exists a well-established between the rotational speeds of the two gears in a gear chain, which is the product of a gear's radius, and its rotational speed is the same for each of the gears. So, if the radius of gear 1 is twice as big as the radius of gear 2, then gear 2 spins twice as fast as gear 1. Similarly, if gear 2 is twice as big as gear 3, then gear 3 turns twice as fast as gear 2, and the speed of gear 3 is 4 times the speed of gear 1. To put it differently, the rate of change between gears 1 and 3 is the same as the product of the rate of change between gears 1 and 2 and the rate of change between gears 2 and 3. Therefore, we can say that the total rate of change is the product of the two intermediate rates of change. The derivative of the function with respect to x using the chain rule. To find the derivative of the function y is equal to log of sine x to the base e, let us take u to be equal to sine x. Then y is equal to log of u to the base e. To find dy by dx, dy by dx is equal to d by dx of log u to the base e. Now, multiplying and dividing by du, we get dy by dx is equal to d by du of log u to the base e multiplied by du by dx. Then dy by dx is equal to 1 by u multiplied by du by dx. Now, substituting u is equal to sine x, we have dy by dx is equal to 1 by sine x multiplied by d by dx of sine x. So, dy by dx is equal to 1 by sine x multiplied by cos x. Therefore, dy by dx is equal to cot x.